know that you're free.
Hello everyone, this is the presentation about differentiation. My name is Wilma, and I'm presenting with Alex and Esta. I will demonstrate the definition of the differentiation and the gradient of tangent. Then Alex is going to talk about 4 rules, and finally Esta will talk about the first and second derivative and the applications. What is differentiation? Differentiation means finding the rate of change of one quantity y compared to another x. Differentiation of first principle means finding the gradient of tangent. The gradient of the tangent. The gradient of the tangent describes the steepness of the slope when the change of 2 points are small enough. In other words, delta x is approaching to 0. The slope can be measured as a change in 2 coordinates given 2 points, x, y, y1, p, x, y, and x2, y2, r, on a line. The slope m of the line is the gradient of the tangent. Now the gradient of the tangent. We assume these two points are close enough, so delta x is approaching to 0, as we can see here. Delta x is approaching to 0, and in this part we can see that fx plus delta x minus fx stands for the right, and delta x stands for the wrong. So to make it easier to understand, we replace delta x with h, so we don't make any confused mistake between x. We get this result, and delta x is approaching to 0, and delta y over delta x, which is the same thing that as we proved in the previous slides. Yeah. Now Alex will explain the rules.
Differentiation is one of the major parts of calculus. Next, I'd like to talk 4 rules related to differentiate. They are general rule, product rule, quotient rule, and chain rule. Let's move to the general rule. If we have a function y equals ax to the power of n, then the differentiation of this function, which I like to use y dash to indicate it, which is y dash equal to this. We bring down n in front of and take 1 off from the power of x and keep a without any change. So this is the chain rule. Suppose we have an example y equals 10x squared. In here, where a equals 10 and n equals 2, what we need to do is just substitute a equals 10 and n equals 2 into the general rule. Finally, we get the answer y dash equal to 20x. Let's move to another rule, the product rule. If we have a function y equals u times v, where u and v are whole parts, which is mean u and v are a single function, then the differentiation of this function, I like to use y dash to indicate it. Y dash equals u dash times v plus u times v dash. Suppose we have an example suppose we have an example y equals 10x squared times 4x squared, where you let u equals 10x squared and v equals 4x squared. In this case, you can find out u dash and v dash. So finally, you just substitute u dash, v dash into the product rule, and then you can find out the answer, which is 160x cubed. This is the product rule. Okay, let's move to another rule, the quotient rule. The quotient rule, if we have a function y equals u divided v, here u and v are single function, then the differentiation of this function equals u dash v minus v dash u divided the square of denominator, which is v square. If we have, for example, y equals 5s divided 4s squared, then to make it easy, we let u equals 5s and let v equals 4x. In this case, it is the same with this one. So what we need to do is just find out u dash and v dash, which is, you get this, and then finally you substitute u dash v dash into this formula, into the quotient rule. Finally you can get the answer y dash equals minus 5 divided 4s squared. So that's the quotient rule. M is example. Okay, let's move to another rule. This rule is the chain rule. If we have a function y equals fu and u equals fx, which mean chain rule is a combination function, then I like to use dy du to indicate this. Then I like to use dy du to indicate the differentiation of this function, which is dy ds equals dy du times du dx. For example, y equals x cubed minus 4 to the power of 4. We let u equals x cubed minus 4, thus we find out u dash equals to this. And let u equals, because we let u equals x cubed minus 4, thus y equals u to the power of 4, which is this. Thus you can find out y dash equal to 4u to the power of 3. Finally we get the answer 12. Finally, we get the answer 12s squared times x cubed minus 4. So that's the chain rule. Next, Esther will tell you.
Going to talk about the first derivative. First derivative is a measure of how a function changes as its input changes. Its value determines the tendency of the slope. For instance, if the slope is increasing, the value will be positive. If decreasing, negative. Before differentiate, we have to confirm the function is differentiable. Simply speaking, that means at a certain point, the function should be smooth and continuous. Stationary points and points of inflection might be kind of confusing, but just remember, stationary points occur when the first derivative equals to 0, and at that point, the gradient will be 0. The points of inflection is a point to change the concavity of the curve. It occurs when the second derivative equals to 0. We use first derivative to prove the tendency of a function. For instance, we can show this function is always increasing by work out its first derivative, then prove it's positive all the time. We also can use it to find out the nature of a function. By the way, nature means maximum, minimum, and inflection. We will talk about it later. We also can use it to help sketch the curve with the assistance of the second derivative. Now let's know more about the second derivative. Second derivative can be gained if we differentiate the first derivative again, and its value determines the concavity of a curve. If the curve is concave up, it's positive. If concave down, negative. This is the example about gaining the second derivative. Now I'm going to talk about the application of first and second derivative. Example 1 is about maximum and minimum problems. A piece of wire of length 12 cm is bent in the shape of a rectangle. Find the maximum area of the rectangle. Firstly, we just represent each side by x and 6 minus x. Then we work out the formula representing for its area. Then we differentiate once to get the first derivative. By making it equals to 0, we can find out the stationary points. Then we prove the function will changes from increasing and decreasing. So this is the maximum turning point. Hence, the maximum area occurs when x equals to 3. Next problem is about determining the nature and sketch the curve. Find any stationary points of this function, then determine their nature and hence sketch the curve. Firstly, we differentiate it once to get the first derivative. Then to work out the stationary points, we make it equals to 0. Then we use table of value. Then it can be easily seen this is the maximum turning point and this is the minimum turning point. To work out the point of inflection, we just differentiate the first differentiation again. Then we use table of value again to work out the concavity. Then we prove the function changes its concavity at this point. Finally, we combine these two tables of value to work out the whole picture. So this is the maximum turning point, and this is the minimum turning point, and this is the non-stationary point of inflection.